Have you noticed how time seems to pass quicker now? Morning turns into night faster than it used to. Most people blame busy lives, but there's another explanation worth looking at. The Earth controls the length of a day, and that length has started to change. We usually think of a day as something fixed. One full rotation of the Earth, 24 hours, no surprises. But in reality, the Earth doesn't spin at one perfect speed all the time. Its rotation can slow down, speed up, and shift in very small ways. And right now, it's spinning slightly faster than usual. Since around 2020, scientists who track time using atomic clocks began noticing something unusual. The Earth was completing its daily rotation just a little sooner than expected. Not by seconds, not even close, by milliseconds. Tiny amounts of time that humans can't feel directly, but machines can measure very clearly. In July of 2024, this change reached a new point. The Earth recorded the shortest day ever measured. One full rotation finished about 1.66 milliseconds earlier than the standard 24 hours. That might sound meaningless. A blink of an eye lasts around 100 milliseconds. This was far less than that. But it matters because we've only been able to measure Earth's rotation this accurately since the early 1970s. Which means this was the shortest day in over 50 years of precise records. So the obvious question is whether this is something to worry about. To understand that, it helps to look far beyond recent history. Hundreds of millions of years ago, Earth actually spun much faster than it does today. Around 600 million years ago, a single day lasted about 21 hours. Over very long periods of time, Earth has been slowing down, not speeding up. That's why the recent change feels strange, but it isn't completely out of place. The reason Earth's rotation changes is because many forces are acting on it at the same time. Some push it to slow down, some push it to speed up. None of them act alone. The sun has a small influence, but not nearly as much as you might expect. Even though the sun is massive, its direct effect on how fast Earth spins is fairly weak. The real driver of long-term change is much closer. The moon. Most of the time, the moon slows Earth down. Its gravity pulls on Earth's oceans, creating tides. As Earth rotates, these tidal bulges don't line up perfectly with the moon. They lag slightly behind, and that creates friction. Over time, this friction transfers energy away from Earth's rotation. Because of this, Earth's days slowly get longer. On average, the moon adds about 2 milliseconds to the length of a day every 100 years. Over extremely long timescales, this process would eventually cause Earth to always show the same face to the moon. But long before that happens, the sun will make Earth unlivable, so it's not something humans need to worry about. Here's where things become less intuitive. Even though the moon usually slows Earth down, right now it's actually helping Earth spin faster. The moon doesn't orbit perfectly above Earth's equator. Its path shifts north and south over time, sometimes moving closer to the poles. When the moon is positioned closer to the poles, it pulls less strongly on Earth's middle and more on the upper regions. That change slightly alters how Earth responds to gravity. During these periods, Earth's rotation can speed up. This effect follows a natural cycle. Nothing is breaking, but it does help explain why Earth is rotating faster now than it was a few decades ago. Still, the moon alone doesn't explain everything. To complete the picture, we have to look at Earth itself. How fast a planet spins depends on how its mass is distributed. A simple way to imagine this is with a figure skater. When the skater stretches their arms outward, they spin more slowly. When they pull their arms inward, they spin faster. Earth behaves in a similar way. When mass moves closer to Earth's center, the planet spins faster. When mass spreads outward, rotation slows down. Earthquakes can cause this kind of shift. When one tectonic plate slides beneath another, huge amounts of rock are pushed deeper into the planet. That moves mass closer to Earth's core. The effect is extremely small, but it's measurable. After the large earthquake in Japan in 2011, Earth's rotation sped up by about 1.8 microseconds. That's far too small for humans to notice, but it shows how sensitive the system is. Water movement also plays a role, and this part often feels backwards at first. As polar ice melts, water moves from land into the oceans. You might expect that spreading water toward the equator would slow Earth down, like a skater stretching their arms outward. And in some ways, that does happen. But there's another effect that matters more. The ice caps themselves are enormous concentrations of weight. Their mass presses down on Earth, slightly squeezing the planet and causing it to bulge outward at the equator. When the ice melts, that pressure is reduced. Earth becomes a little more evenly shaped, a little more compact. And when that happens, Earth spins faster. Each of these changes is tiny on its own, but together they add up, enough to shave milliseconds off the length of a day. This leads to a practical issue, even if most people never notice it directly. Earth doesn't rotate perfectly smoothly, but atomic clocks measure time with extreme precision. To keep clocks aligned with Earth's rotation, scientists occasionally add what's called a leap second. The most recent leap second was added in 2016. That means when we say a day is 24 hours long, we're rounding. It's actually slightly longer. If Earth continues to rotate faster, we may eventually need to remove a leap second instead of adding one. That would be a first. It wouldn't affect daily life for most people, but it could create problems for systems that rely on precise timing, such as GPS networks, satellites, and financial systems. For everyone else, this remains an interesting detail about how dynamic our planet really is. It's not a threat. It's not a warning sign. It's just a reminder that Earth is always changing. What deserves more attention is something much farther away. Recently, NASA released new footage captured from inside the Sun's outer atmosphere. The images were taken by a spacecraft called the Parker Solar Probe. For the first time, we're seeing the Sun's corona up close. The glowing shapes are massive clouds of superheated plasma. The streaks racing past the camera are particles from the solar wind. The solar wind is a constant stream of charged particles flowing outward from the Sun. Earth is usually protected from it by a magnetic field, which deflects most of these particles into space. Sometimes that interaction creates auroras near the poles. But the Sun doesn't always release energy gently. Every so often, it launches a huge burst of plasma into space, called a coronal mass ejection. If one of these hits Earth directly, it can disrupt satellites, damage power grids, and interfere with communication systems. The Parker Solar Probe was launched in 2018 to help us understand these events better. In 2021, it became the first spacecraft to enter the Sun's corona. Since then, it has used Venus's gravity to swing closer and closer to the Sun with each pass. It is now flying just over 6 million kilometers from the Sun's surface, closer than any spacecraft has ever been. It will continue making these close passes, gathering data from regions we've never studied before. One of the biggest mysteries it's trying to solve is why the Sun's outer atmosphere is so hot. The Sun's surface is about 5,500 degrees Celsius. The corona reaches millions of degrees. That shouldn't happen, based on what we know about heat, yet it does. Another mystery is how the solar wind is created and accelerated. We know it exists, but we still don't fully understand what drives it. Understanding these processes matters. One day, a very large solar storm will hit Earth, and when it does, modern life will be tested in ways we've never experienced before. Power failures, communication loss, satellite disruption. Not for minutes, but possibly for days or longer. So if you're deciding what to worry about, Earth spinning slightly faster shouldn't be high on the list. The planet is fine. The Sun, however, is a reminder that we live next to something powerful, unpredictable, and far beyond our control. If you enjoy calm, clear stories about space, time, and the forces shaping our world, this is exactly what we explore here on Astrion. Consider subscribing so you don't miss what comes next. Sometimes understanding what's happening doesn't make it less unsettling. It just gives us more time to think about it.